8 and 7, lesson 3, existence and uniqueness of square roots and cube roots. Well, this is more just about square roots and cube roots and not necessarily so much about the existence and uniqueness of them. And talking about, we know what square roots and squares are, but we add in the concept of cube roots and cubes, and let's talk about that. And then we'll have, there's 3 different kind of homework problem types that we'll talk about in the course of the lecture, and then there'll be some homework help that will work those problems out. So let's get to it on the scratch pad. So let's just talk a little bit about what we know to be true. So this is just kind of a little bit of a summary, and we'll talk about what it means to be a square. So if a number, so we're going to talk about a number squared and then some examples of what that looks like. So sometimes we say x squared, you know, like 6 squared. What does that mean? Well, it also can be represented x to the 2nd power. That's said to be x squared, and that would look like this. And these, by the way, these are all the same. These are all equivalent. And I'm just saying it in different ways because your teacher might say it differently, or you might see it in a word problem differently, or on the board differently, whatever. So x squared is also x times x. It's just x times x. So it'll look like 6 times 6. And then finally, you might see squares, meaning the area of a square that has a side of x. So this is where we get the word squared from. This is where the word squared comes from. When you see this, why is this not x to the 2nd power, which it is? Why do we sometimes say x squared? Well, it's because if you put a number like 6 or x on the side of a square, the area of the square is the same as 6 squared, or 6 to the 2nd power, or 6 times 6. So the area is 36, and they say square inches. So that's where the word squared comes from, why it's x to the 2nd power. Now, on the equivalent side, you have this thing called the square root. And this is kind of it kind of undoes squaring. It undoes squaring. So if I square a number, so I take 6 squared, and then that equals 36, and I take the square root of 36, that's going to get me back to my original 6. So a square root, that's why we say the square root undoes squaring. Okay, so let's keep going. So you'll sometimes see it as said the square root of x, like the square root of 25. An equivalent way of saying that is you put this radical. This is called a radical sign. And it's implied that the square root, it's implied that there's a little 2 here, but sometimes we don't draw the 2 if we see the radical sign. We understand that this means the square root if there's no number here. But sometimes there's a number here, and we're going to talk about that in a second. Sometimes there's a number there. So the example would be the 25 under the radical sign. This is the same thing. It's the square root of 25. Another way of saying it is what times itself equals x. So what times itself is 25? What number, if I multiply it by its, by itself, would equal 25? What positive number, really? What positive? Because we learned last time that negative numbers times a negative number could also give me 25. But we specifically want the positive number. Or you could say, what is the length, the side length of a square with area x? This is another way of finding the square root. So if I have a box, a square, and it has sides of, we don't know what its sides are. If we had a 25 inside the box for its area, the side that would fit here for this square, which would be 5, it would be its square root. So 5 times 5 is 25. So 5 is the square root of 25. You could see it in any of these ways. And you'll see this in a lot of word problems. You might see, so you say, why would anyone say this? Well, the reason they'd say it is because it was in a word problem, and we'll get to some of those in a little bit. Okay, so let's look at the equivalent, and we're going to learn about cubes. So you may already know what a cube is. I think it may have been talked about in a prior lesson at some point in time. But we're going to go through this exactly like we did the squared thing. So you might see it said x cubed, which is the same thing as x to the third power. Not to the second power, to the third power. And it would be x times another x. So that might look like, whoops, let's get rid of this. It might look like x 6 cubed, 6 to the third power, or 6 times 6 times 6, which would equal 216, by the way. Or you might see it's the volume of a cube that has side x. So if remember, a square was the area of a square that has side x. So this is two-dimensional, right? A square is two-dimensional. But here we have a cube. So the volume of a cube is the length times the height times the width, if you will. Doesn't matter which is the length, the height, or the width, but it's 6 times 6 times 6. So that's why you hear the word cubed. That means a number multiplied by itself 3 times. Right? So x times x times x. And that is the geometric representation of cubes. Okay, so now let's talk about cube root. So it's the same thing as a square root, but with, a cube. So the cube root of x looks like the cube root. You might see the cube root of 64. You might see it look like this. Now here's where we actually draw this number in 3, because otherwise, if we just wrote it like that, that is implied to be a square root or a square root. That's the second root. But this means we're looking for a number multiplied by itself 3 times that gives you x. 3 times, what number multiplied 3 times will give you this number? What times itself times itself? What times itself equals x. So x times x times x, or what times what times what equals x. So what times itself equals 64. That's what this is saying. Or you could know what the volume of the cube is. If you knew the volume is 64 cubic inches, what is the side length that would make it have a volume of 4, where everything has to be the same? And the answer here is 4, by the way. Because 4 times 4 is 16 times 4. 4 times 4 times 4 equals 64. So the cube root of 64 equals 4. So. Okay, so we're going to be looking for these types of numbers. All right, so let's move forward. You know what? Let's give ourselves a happy cat, because this is a cool concept, this cubic thing. And we're going to see some examples here in a second. Okay, so let's work on these examples and really make sure we get it. Maybe you could try on your, if you're advanced, try it on your own, and pause. I encourage you to do that here. All right, so 2 cubed. So I assume you're back. I assume hopefully you've tried some of these. So 2 cubed is the same thing as 2 cubed, which is the same thing as 2 times 2 times 2, which is equal to 8. Right? 2 times 2 is 4. So that's 4. 4 times 2 is 8. So 4 cubed is the same. You do it the same way. 4 cubed is 4 times 4 times 4. And that is equal to 64. Now we say, ask a different question. And this is the same question, but asked differently, like a word problem. What is the volume of a cube with side length 9? Well, let's just draw that cube. And it's got height of 9, a width of, or a length of 9, and a depth of 9, whatever. It's basically, you know, the 3 dimensions multiplied by each other. But this is a perfect cube. So it's 9 times 9 times 9. And so that equals, well, let's do it. 81 times 9. And I can do this one in my head, but I'll show you how we can do this one in your head, because there's our 9, and then we get 729. And because this says centimeters, these are cubic centimeters. So there's our cubes. Sometimes cube roots are a little bit harder than cubes, because here you just do a straight multiplication, but on the cube roots, you got to think of a number that multiplied by itself 3 times will give you 8. Well, let's see. Well, 1 times 1 times 1, that gives you 1. Well, 2 times 2 times 2. Well, there's 8. So these 3 numbers multiplied together will give you 8. So that's equal to 2. Similarly, the cube root of 27, well, the cube of 4 is 64, so that's way too big. So the only other number, if 2 cubed is 8 and 4 cubed is 64, it seems like it has to be 3, but we can test it out. 3 times 3 times 3 equals 9 times 3. Well, that's 27. So the cube root of 27, because 3 times 3 times 3 is 3. Okay, so hopefully these are kind of easy. I'll show you another way that can help you with solving these types of problems here on the next slide. But let's just get into the third. This is one type of question where they're going to ask it to you a couple times on the homework. So I'm going to show it to you, and you're like, oh my goodness, this -1. I don't remember what that means, Mr. Lipscomb. Well, all that means, remember, x to the -1, anything to the -1 is equal to 1 over that number to the first power, which is the same thing as just 1 over that number. So this question, to make it simpler for you, might look like this. X cubed equals 1 over 64. Now, you say, well, what times what is 1 over 64? Well, that might be kind of hard to think about, but all you have to really do to figure this one out is know what the cube root of 64 is. And watch, what is the cube root of 64? The cube root of 64 is 4, because 4 times 4 times 4 equals 64. So the cube root is 4. So watch how I do this. So then I say x cubed equals 1 over 4 times 1 over 4 times 1 over 4. There's my cube. Right? 1 over 4 times 1 over 4 is 1 over 16. Times 1 over 4 is 1 over 64. So it's really not that hard of a problem when you think about it. So just remember, so don't let these fractions screw you up. It's pretty much the same problem as solving the cube root of 64, once you see 1 over a number like this. So the cube root of x cubed is equal to 1/4. Sorry, the cube root. So x is equal to 1 over 4. Okay, now there's a problem that I saw in the book today, and it said, what is the cube root of 2,744? And so we got to find out what 3 numbers multiplied together equal 2,744. And I don't know that. There's no one who memorizes that except for maybe one really a person who's, I don't know what they do with their time, that memorize big numbers like this. So the key, let me just tell you how you do it if you don't know the number. The first thing you do is you get a prime factor of the number, prime factorization of the number. And then we're going to use the associative property of multiplication to form 3 equivalent groups of numbers. And so that multiplied together give me that number. But let's just do this one step at a time. And I'll show you how you can use this to your power. So 2,700, and if you don't know how to do it, well, I don't know what the factors of this are, so I'm just going to take out a 2. So that leaves you 1, 3, 7, 2, right? 1, 3, 7, 2. Well, this can also be divided by 2. So that leaves me 6, 8, 6. Right? If I divide that by 2. Now I'm going to divide this by 2. Because I know that that will divide by 2. Because these divide by 2 because they're even numbers. So those are easy things to solve. 343. Okay, now 343, that's kind of a tricky number. Well, it doesn't divide by 2 because it's odd. It doesn't divide by 3 because the numbers don't add up to a number that divides by 3, right? That's the trick. If 3 plus 4 plus 3, well, that's 10. That doesn't divide by 3. So this number doesn't divide by 3. If any of you don't know this rule about how to find out numbers that divide by 3, ask your teacher and work on that in class. Or maybe I'll do a video on it some other day. But this doesn't divide by 3. It doesn't divide by 5 because it doesn't end in a 5 and it doesn't end in a 0. So let's see if it divides by 7. 7 into 343. Well, that's 4. 4 times 28. 63, 49. Yeah, so 7 times 49 is 343. So 7 times 49, and then 7 times 7. So prime factorization says that let's do this in a different color because we've actually done some cool work so far. So 2,744 equals, let's circle our prime factors. 2 times 2 times 2 times 7 times 7 times 7. Now the key thing to do is to use associative property to form 3 groups of numbers that are all the same. Wow, well, I can see 3 groups of numbers that are the same. I can see a 2 and a 7, a 2 and a 7, and a 2 and a 7. So I can write using the associative property of multiplication that 2,744 equals 2 times 7 times 2 times 7 times 2 times 7. So I'm just now going to do this to make it really obvious for you. And so now I can say 2,744 is equal to 14 times 14 times 14. Whoa, I think I got it. 2,744 is equal to 14 cubed. So the cube root of 2,744 equals 14. And that's worth a happy cat. And you can use this technique on any number that you can't figure out the cube root for. Just write down all the prime factors and see if you can make 3 groups that are the same. 2 and a 7, that's group 1. 2 and a 7, that's group 2. 2 and a 7, nice and even, that's group 3. So I have my cube root of 2,744 is 14. Okay, so let's now move on to some homework help. Hopefully that was fun for you. That was really fun for me. So let's look at, what do we have here? We have some word problems. And so I want you to see if you can use what we've learned to solve these word problems. So we have a square garden that has a side of 13 feet. So we have a square garden. It's got some flowers in it. Can we find flowers? Oh, look at this. Oh, we're going to have a lettuce garden. Look at that. Oh, no, that's a tree. Oh, well, let's just pretend it's like broccoli. We have a little broccoli garden. A broccoli garden outside. Cool. And in this broccoli garden, Happy Cat's watching the broccoli garden. He's watching the broccoli garden, hanging out. Whoops. Okay, and each side is 13 feet. So the question is, what is the area of the garden? All right, and then over here we have a cube. Whoops, that's not a good cube. And it has a volume of 64 cubic inches. And so we have these sides, and the sides are all the same length, right? That's the definition of a cube. It's like a square, but it's three-dimensional square. So pause and try. Okie dokie, we're back. Okay, so what is the area of this square? Well, we know that the area of any square or rectangle is just the length times the width. You know, and in a square, that's the same thing as the length squared or the side squared. So we just say 13 times 13. And that's 169 square feet. And that's it. That's the word problems that you're going to see a lot with squares. Now, a cube has a volume of 64 cubic inches. So here we have to say, you know, x, length times width times height, equals 64 inches cubed. So x cubed equals 64. So what times what is 64 square inches? Well, we've learned this actual pattern earlier, or this actual number, and we know that that's 4 cubed equals 64 cubic inches. So x in this case has to be 4 inches. All right, let's move along. Here we have some algebra problems, and this is our final homework help. Our final homework help. Find positive values of x that satisfy the following equation. So remember this is 216 to the negative 1 power. Okay, well, here we go. So I want you to pause and try. Okay, assume you're back. So let's just do our math. Let's simplify this first, though. And let's see if we can make this simpler. Well, we're going to take 2x from both sides, and we're going to get this thing a little bit simpler really fast. So x squared plus 4 is 29. Subtract 4, and we get x squared equals 25. We only want the positive value. So what times what is 25? Well, that's 5. Number 2, we have this negative 1 problem. So here we have x squared equals 1 over 81 to the first power, or just 81. 81 to the first power is 1. So what times what is 1 over 81? Well, we learned the trick here earlier this lesson. So all you're pretty much doing is you're finding the square root of 81, and that's 9. But then you have to turn it into a fraction, or 1 over that. So x squared equals 1/9 times 1/9, because 1/9 times 1/9 equals 1 over 81. So then x, right? So we have x times x. This is just another way of showing your square roots. Well, if x times x is 1/9 times 1/9, then x is just 1/9. Another way to think about square roots is to kind of draw it like this. Our x squared equals something times something that's the same, and then we have x times x equals that same thing times that same thing. So x must equal that thing. All right. Finally, we have x cubed equals 216. So x cubed equals 1 over 216. And now remember, we don't know what the cube root of 216 is maybe. So let's use our trick where we do use our tree. Well, 216 is equal to 2 times 108. and that's 2 times 54, and that's 2 times 27, and that's 3 times 9, and that's 3 times 3. So we get 216 equals 2 times 2 times 2 times 2 times 3 times 3 times 3. And now we can make 3 groups that are all the same. So 216 is 2 times 3 times 2 times 3 times 2 times 3. And all we've done is we've switched these numbers around, which we can do because of the associative property. And so 216 is 6 times 6 times 6. So 216 is equal to 6 cubed. So the cube root of 216 equals 6. Well, if the cube root of 216 is, so let's take this over here. So if the cube root of 216 is 6, then x cubed in this case is 1 over 6 times 1 over 6 times 1 over 6. Remember, which is 1 over 216. So then x is equal to just 1/6. Okay, hopefully this was a useful lesson. Hopefully you got some good homework help and some homework tips out of this problem, or out of these videos. And we're rocking and rolling on what is truly the last module of the school year, module 7. And we got to go to lesson 23 to get all the way to the end. So congratulations. Doing pretty good work here. Doing great work here. We'll be on lesson 4 tomorrow, and we'll see you then.